Hello. So we're looking at problem 9.4 in the free-form activity. And as I've said before, the parameters of the problem change every time you open this problem. So when you open it, it may look different with different values. Well, let's focus on the process of solving it. So we have a study that tells us that the average per capita consumption of milk in the United States is 21.5 gallons. And being from the Midwest, you believe that the milk consumption is actually higher than that. So you want to test your hypothesis. So you take a sample of 14 individuals, that's a small sample, and you ask them how much milk they consume each year. And we give the data in the spreadsheet that we'll look at in just a moment. Well, let's look at setting the problem up first. I'm going to pause and show you a diagram. So what we have is a very bad sketch of a normal probability curve with a standard mean of 21.5 gallons. Now, what's missing is our sample mean and our standard deviation. And what's key to understand that we don't know the population standard deviation, which means we'll have to use the sample standard deviation, which we'll need to calculate from our sample data. So in going to the sample data, I brought over the standard mean because one of the problems that we read asked for the difference. So we need the standard mean that we were given. We determine the sample mean with the average built-in formula and the sample standard deviation with the built-in formula for the sample standard deviation. And using just a simple calculation, I calculated the difference between the means. This is the point estimate of the difference between the means. So back to our diagram, we now know we have a sample mean of 24.88 to 2 decimal places, a sample standard deviation of 4.777, and our point estimate of the difference is 3.3814, although we probably won't need it to that many decimal places. So in developing our hypothesis test, it's always a good idea to think about what it is you want to claim or what it is you would like to show. I can't say prove, but what claim would you like to make? Because we believe that the milk consumption is higher than the standard we were given, then we want to put our claim in the alternative hypothesis. We'd like to be able to show that the average milk consumption is actually greater than what we've assumed as the standard, 21.5. Therefore, the null hypothesis should be just the opposite of that, where the mean is less than or equal to 21.5. And always remember, any equality should be in the null hypothesis, never in the alternative. We calculated our point estimate for the difference at 3.38. So check those just to see our progress, and we're on the right track. Next, we want to do a test of whether or not that difference is significant with an alpha, a level of significance of 0.05. So let's switch to our statistical toolkit to determine whether or not that's a significant difference. So in our toolkit, we have several hypothesis testing tabs. One is the hypothesis test for the mean, where sigma is unknown. This is the one we want to use because we don't actually know the population standard deviation. We only have the sample standard deviation. And you should recall that if you're looking at a mean where the sigma is unknown, what you're going to be using is a t statistic, not the z statistic, a t value as opposed to a z value. So this tool is set up to enable you to do a lower tail test, an upper tail test, or a two-tailed test. Both the lower and the upper tail test are one-tailed test. And if you look at your diagram, we're looking for a value in the upper tail. We want to know if we are greater than the mean. So in the green areas of my upper tail, one-tailed test tool, I've entered in the standard mean, 21.5, sample size 14. The sample mean was 24.88, and the sample standard deviation of 4.777. And the level of significance that we're using for this test, 0.05. So this gives us a calculated t-value, the value of the test statistic, of 2.647. Our p-value is 0.01005. And this allows us to reject H sub 0 because our p-value is less than our level of significance. And you notice it's very close to 0.01, but we're using a level of significance of 0.05, so we are less than our alpha. So going back to check our work, the value of the test statistic, the t value, rounded to 2 decimal places, 2.65. The p-value rounded to 4 decimal places, 0.0100, which allows us to reject the null hypothesis and conclude that the population mean consumption of milk in Webster City is greater than the hypothesized mean. So folks in the Midwest of Webster City are drinking more milk on per capita than that study indicated. So obviously the key in this problem is to make sure that you are defining your hypothesis test properly. I think the diagram helps in that, so always draw a diagram of the problem. And secondly, recognize whether or not you have the population standard deviation. If you do, then you can use the hypothesis test where sigma is known. If you don't, then use the tool that involves the hypothesis test where sigma is unknown, and you're using the t statistic, the t value, instead of the z value. And of course, the last thing you should keep in mind and notice about hypothesis testing is that it's very sensitive to the alpha that you choose. Had we chosen an alpha of 0.01, which is oftentimes the other case, we still would have rejected the null hypothesis, but it would have been very close, because you can reject the null hypothesis if the p-value is less than or equal to alpha. At a 0.05 level of significance, of course, we were much less than alpha, and rejecting the null hypothesis was very clear.